Today in the AWS Developers Podcast, we're talking about the multi-agent orchestrator, an orchestrator for AI agents. We're going to clarify all that. Stay tuned. Good morning, good afternoon. Thank you for joining the AWS Developers Podcast every Friday morning in all your podcast applications, Spotify, Deezer, YouTube, without the video, just the audio, Apple Podcast as well, on the web as well. You are more and more to subscribe. Don't hesitate to subscribe so every Friday morning you receive the new download in your apps. Today we are going to talk about generative AI for once. And we are going to see some of the challenge of actually doing a Gen AI solution that works. And I have the pleasure to welcome two guests today, prototyping architects Corneliu Croatoru and Anthony Bernabeu. You're both part of the French team in the prototyping team, so your job is to create prototypes for AWS customer. And you came up with a framework, an open source solution. We're going to describe it, which is called the multi-agent orchestrator. Before diving into the details of why and how, what is it?
Thank you, Sebastian. Happy to be here today with you. Yeah, so I would say what it is. It's something that allows you to build Gen AI applications where at some point you want to have some pieces of code, I would say, that are able to respond to different kind of questions, I would say, or usages. Which means in that case, you would need to build multiple agents, right? Because as a best practice is whenever you have more than one kind of questions or domains that needs to be covered, you need to split it into agents that could be smaller or bigger, right? And in that case, you would need something to orchestrate them. So here comes our framework that allows you to do that and can do this for various type of applications.
Yeah, I remember when I played in the Amazon Bedrock console, I was a bit frustrated because I managed very quickly to create a knowledge base or to create an agent. But when I was testing them in the little chat, which is provided for developers only, it's not an end user product, the chat was able to only answer the question specific to that agent or to that knowledge base. But if I want to step out and have like larger conversation with the models under Bedrock, it was not working. So what I realized is that as a developer, I need to write some kind of routing mechanism that analyze the questions and depending on the question, sending to one agent or the other knowledge base. And this is where I stop because obviously it's a lot of code to work and that was beyond my scope. But if I understand well, that's the specific problem you're trying to solve with the multi-agent orchestrator is that open source framework is like an orchestrator. It's a router of questions to the correct Gen AI model or agent.
Yeah, exactly. I would say it's a smart router, which allows you to orchestrate, for example, Bedrock agents, more than one, but also different kind of agents. Could be Bedrock agents, could be a Lexbot, could be maybe a local running LLM or a short, small model running locally or not, different kind of agents for different kind of usage based on your needs.
Yeah, your solution is much broader than just quote Amazon Bedrock generative AI models. It can talk to different types of models, also at different place. Where the idea came from? I said in the introduction, you're working mostly with customers to do prototyping for them. So what was the use case that triggered this development?
So this project started about 8 months ago. We were engaged with a customer in the bank area. The idea was to actually reduce customer support workload for basic operation, like for example transferring money from one account, paying a bill, or being able to add a beneficiary to an account, and also some more general question about card or account that the company may offer. So the customer at the time had built something using Amazon Lex, where they were looking at how generative AI could help them in facilitating bots or agents. And also one of the crucial aspects of the solution was when we needed to switch conversation. So I might have started to I want to pay someone, for example. So I want to pay Sebastian for the concert we went yesterday. Yeah. But then I realized that you are not part of my beneficiary list. So I need to add you and then go back to the money transfer. So this was for them like the crucial aspect of the solution. And when we started to engage, I think our idea was, even at the time, to orchestrate multiple agents. So for them, it was Lexbot and maybe some basic knowledge base. But having all of those agents available through a single conversation, not having different endpoint or different chatbot,
It's really important to understand that if you build a chatbot, for example, for your customer, not one single model or not one single knowledge base or agent is enough to answer, to cover the range of questions. As Cornelius said in the introduction, you really need to specialize your agents, and then you need to orchestrate them. And what is the main challenge to orchestrate them? It's just the diversity of the API, authentication methods, and data format, or do you have any other specific technical challenge to address to be able to orchestrate multiple agents?
I think if we look at what we built or what we explored like 8 months ago, I think the challenge was on the model available. When we did start looking at this, the best model that we had on Amazon Bedrock was Claude 2.1. And at that time, being able to classify the request to the right agent, when you had like few iterations already, and then when you started to do like some sort of context switching, I think, returning on the user's question with the history and the context and the agent available was completely working, I would say. And as time evolved and model became like more powerful, we rebuilt all this kind of exploration phase that we did, and built this framework. And today, the challenge that we have regarding this is, of course, being able to support maybe multiple providers. So in our orchestrator, for example, we support Bedrock, Anthropic, OpenAI, Olama, which is already like a long list, and also some other AWS services like Lex or AWS Lambda. But I think also the challenge is when you want to start to build something like this, you need also to think about how you orchestrate your classifier, how you make them working as one intelligence, I would say, through a single conversation, and also all the aspect of maintaining or saving the conversation history to be able to remember what was happened for the agent and for the classifier to really being able to route the request to the right agent. At the end, this is what we want, right? From one request and follow-up question or response, you need to go to the right agent.
And that's what we are going to talk about, how it works behind the scene. Maybe let's follow a question from an end user. Let's start with a use case. You developed 2 or 3 different use cases that we can find on the GitHub repo. Let's take one and follow the flow from the user question to a couple of conversation turns and then a final answer.
We can do this. So, for example, we have built one implementation that is able to demonstrate how this framework can be used, because it can be used in several ways. And one example is how to build a e-commerce support system that has AI agents and human agents to respond to customers' emails. Right? So, for example, if you send an email saying, "Hey, I bought a product yesterday, I placed an order, I don't have any updates. What's the status of the order?" Or, "I want to cancel my order. This is my order ID," right? So how it works, we have several agents built for this implementation. How the framework works is that each agent is able to save its own conversation after the response, which means the agent has the chat conversation history for that same session, right? So each agent has a different chat history separated, so they don't share it. But the classifier, when he needs to classify and select the right agent, it uses the user request, of course. It uses the description of each agent that is basically set when adding agents in our framework. So independent of the description of your agent, like, for example, Bedrock agent is like a different one. And it uses also all the chat conversation of all your agents with the name of the agent that gave that response for the each response, which means he knows who said what for a customer user input, and by using this, is able to understand what is the best agent. And for example, the simple use case when you say I want to see the status of my order. This is simple, right? But for example, if you ask this and you have an agent that says, okay, give me your order ID, and you respond 1, 2, 3, 4, 5, this is just numbers, right? So it's really hard to say, okay, what the number means, right? But because the classifier has access to all the conversation of all agents, she's able to understand in multiple conversations which agent needs to be selected because I'm responding to a question that one agent asked me at some point.
So that's the flow. Your agent is, well, your framework is the orchestrator. And the first question from the customer arrived to your frameworks. Then what's next? You're calling the classifier, if I understand correctly?
Yeah, so you have always a single entry point. You don't have to call the agents yourself. You have an entry point. You say, process this request. This basically gets into the orchestrator, which calls the classifier. The classifier responds with a structured output, like a JSON, say, selected agent, this one. Then takes the user input, send it to that selected agent, if there is one, because it can be like non-selected. The agent then generates the response. And this is interesting because we build in such a way that each agent can respond in either a streaming way or a request response mode, which means based on how that agent can respond, it will respond. The framework is able to fetch the responses either in chunks or response at once. And then, of course, you get the response once the agent starts responding. Like I said, either in chunks or at once.
And then the framework save that conversation for the next turn of
exactly. So the framework
questions.
Orchestrates the saving of that chat history after the agent generates the response. And then when you call the second time, that framework is always fetching the conversation of all agents, is going to concatenate in front of each response the name of that agent that gave that response. Say, okay, classifier, this is the agent that I have. This is the chat history. This is the user request. Tell me which one is the agent that needs to be selected now.
And that orchestrator, it's quite light in terms of CPU and memory execution. It's not where the GenAI model is running. It is just, quote, a router that will send requests to other machines. So it can run into a Lambda function or a light Docker container.
Yeah, exactly. It can run, I would say, everywhere. Right?
On my
locally,
laptop.
can your laptop and Lambda function and whatever in like chainlit application. Of course, if you call, for example, by default implementation for the classifier is calling the Bedrock API for using Cloud and the agents. But you could use, for example, a local classifier based on your needs. If you maybe you need something that needs to run maybe faster, you could like have a local classifier, which means you have an implementation for the classifier. By the way, each block of the framework allows you to bring your own implementation for the classifier, for the agents, for the storage, and so on.
That means that you cannot guarantee the result if the classifier can be changed, if the model used by the classifier can be changed by the end user, or I mean the developer. How can you guarantee that the return of the classifier will be good enough so that you can route the request to the correct agent?
I would see this in a different way. I would see this in a way where you can, if what we did as default doesn't fit your needs, you want to do something better, you can go and work and customize even more because we have a prompt in the classifier, right? But maybe you can do it better because maybe use a different model, which needs to have a different prompt. So you can do it. So I would say see it in this way where you can improve it even more, not make it worse.
Yeah, and also I think something interesting is as part of the framework, I think we have tools to be able to, as you are like having like multiple agents, trying to see like how much overlap exists between those agents, so that gives you an idea about like how much agents are like sharing a bit of the same kind of meaning, and see how this would work then when you start putting this together. Because I think the main challenge is as you are like adding more and more agents, they might have like a bit of overlap. But because everything is flexible, you can always customize the prompt to make sure that your request will be tied to one specific agent.
What does it take to add an agent into the party? If I'm a developer using your framework, I just receive a new agent from another team in my company. How do I describe what this agent is doing? Is it a prompt that I have to write? Is it like a contract, like an open API document? How does it work?
So the way it works in our orchestrator is when you want to add an agent, so we provide like default kind of implementation. So we mentioned Bedrock agent, for example, or Bedrock API. So you can create like a Bedrock LLM. You provide an agent a name and a description saying this agent is able to answer like technical question about a knowledge base, for example, that I have built. You provide like information about whether you want this agent to be able to stream the response on what is like the inference configuration of that agent. And that's it. Then you can add it to the orchestrator. This is when you are like trying to build your own agent. When you have like, for example, agents that are already available, like for example, agents for Amazon Bedrock, what you need is to provide like the agent alias ID and the agent ID with a description and the name, and the same mechanism will apply. So you add this agent to the orchestrator, and that's it. It is part of your overall framework.
So an agent is always Gen AI based, or can I have an agent which is just an API?
Yes. So within our framework, we provide also implementation for Amazon Lex, which is not an LLM, or which is like not really like a generative AI. Mm-hmm. We also have provided the implementation for using a Lambda, for example. You might have a Lambda that is already like doing something, whether it's LLM based or not. You can also add it to your orchestrator. And also API as well. We provide the implementation for that. So you might have already an API working somewhere. And then you can just add it to the orchestrator by providing this is like an API agent. You provide the description and same thing. You know, the orchestrator needs to know, notice the classifier, what is this agent name and what this agent is able to do. And that's it.
So let's imagine I have a restaurant. I have already an agent that is able to chat with my customer about current status of a reservation, but I also have an API to make a reservation, for example. I can integrate all that, maybe an agent for the menu as well, and create one cohesive, complete experience for the end user that combine these different agents and API. Corneliu, you wanted to add something?
Yeah, I want to just mention that. So we have some built-in agents, like Anthony said, but you can also create your own agent. Regarding the question, like all the agents need to be AI. No, in our vision, an agent is something that does something. I would say, right? So you could build your custom agent, and essentially using the framework, you just need to extend the base agent class, and then provide implementation of a single method, which I think is called process request, and that's it. Based on what want that method to do, this is what your agent will do. So it could be maybe calling an LLM, or could be something, maybe some mathematical thing, or maybe some semantic analysis or whatever. So it could be anything. There is no limitation because you provided implementation.
I saw something on Amazon Bedrock that looks a bit like your framework, and I would like to understand the difference. On Bedrock, there is that Converse API. There is a podcast episode about it where we talk about the Converse API. But basically, at least from my point of view right now, but maybe you are going to make me change my mind, it looks a bit the same. Like the Converse API, I tell, hey, these are the tools I have. This is my question. Which tool can I use to answer that question, and the Converse API performs some kind of classification as well to route a specific request to a specific agent or API. So what's different with your framework?
So I would say it could be seen as a similar, but not that much, because what you are saying is true, but this will fit in a single agent, right? If you have, like you said, like an agent that gives away, for example, the restaurant menu, another one to take orders, I could see this maybe as a two agent. I mean, it needs to be analyzed, but which means each one will use the Converse API with some tools. So each one of your agents will have different tools, and then the agents will be able to make that, process that request.
So the Converse API from Bedrock is to create one agent, and your orchestrator is to orchestrate multiple agents. Can I summarize it like that in my head?
Yeah, you could see it like this, yeah. Because, for example, we have one implementation of Bedrock LLM, which is using the Converse API to call Bedrock, use the tools, and then do the implementation.
You've been working on this framework in several months, and you are using it on a daily basis to implement prototypes for customer. Can you share a couple of use cases that you implemented with this framework?
Yeah, so we released this end of July in the TypeScript version, and 1 month later the Python version, because this was basically the main ask after the TypeScript. Yeah, so I've been using already in two engagements so far with customers. For example, I have my recent one where, for example, there's an internal chatbot where I have two agents. One that is able to translate the user request in a fields that will be applied to a SQL query, for example. Right. So this agent will give me a structured output, and I have, for example, another agent that is able to respond me about some general questions on a different domain than the first one, that is using, for example, a knowledge base with some documents uploaded by the customer.
You also published 3 different use cases that are published on the GitHub repo, and there are long blog posts that goes with that. Can we share in details 1 or 2 of them?
Yeah, I think Cornelius shared the one regarding the email support. The other one that we shared recently is something. So it's an agent, but then we try to make it able to speak. So what we did is we built an orchestrator with 3 or 4 agents. One is able to book you a flight, and this goes to Amazon Lex. We have another one which is able to give you advice for jet lag, for example. Another one which is related to technology. So let's say I'm flying to the US, whether my power adapter from my Mac will work or not, and do I need something else? And the other one, I think it's related to the weather. So let's say I want to go to Barcelona if it's sunny or not. So we built this orchestrator available through a chat interface, right? So you can write something and get a response. The idea is how we can make them available through voice. And this is where we decided to look at Amazon Connect and integrate Amazon Connect with our framework to be able to ask something, say, I want to go to Barcelona. Yeah, let's go through the booking information, and then in the middle of the conversation, I can say, by the way, if I come from the US, there is 8 hours different. How can you help me in avoiding jet lag, for example? And then through the same conversation that you have through voice, you are redirected to another agent. From a user perspective, you are not moved around. You stay within the same line, and the same voice is interacting with you. So it was another aspect that we try to show to customer, how you could also voice enable your agents with our orchestrator and with other AWS services, again, to reduce maybe workload on your customer support for something basic.
Yeah, the idea would be in that case that the agent handles the start of the conversation and redirect to a real human person through Amazon Connect only if it is necessary or at some step in the conversation. Amazon Connect, if you never heard about that, it's a call center as a service. It's a system that allows to manage incoming audio encode for your human agents that are taking calls, and you can orchestrate that and monitor that. And you mentioned another service a couple of times already. I didn't react. It's Amazon Lex. Lex, it's a how can we define Lex? It's a conversational interface. It's like Alexa as a service. If you want to put an agent that has multiple conversation turn inside an app, but without generative AI, that's what it proposes.
I would not be something that Lex allows you to build a predictive flow, which is not the case when using LLMs.
Mm-hmm.
That's why it'd be a good approach to have different agents. Some of them could be Lex agents, and some of them could be LLMs. When you have some flow which needs to be specific and fixed, like money transfer, you want to know what's happening, right? If you give this LLM, it could work.
Or not.
9 out of 10 times, but maybe not all the time. Where Lex is different in this case.
Yeah, Lex is based on intent, the structure of Lex. So there is machine learning as well to recognize your voice or your text and translate this into intent, and then we trigger actions based on this intent. So it's much more predictive. I like the analogy between predictive Lex or a bit less predictive generative AI. What did you learn by developing this framework? What was the Sorry, I have two questions. The first one was the challenge that you had. Did you encounter some unexpected difficulties? And then from there, what did you learn?
I think, when we started, the main challenge was really about the technology that we use. I mean, I think we got the idea, but as I mentioned, LLM were not there. So for us, it was a bit frustrating to try to build something, which we knew was working as you are like adding more agents and having a full conversation. And then all the learning that we got for going into that release of this kind of open source project is mostly about like sharing experience with other colleagues as well as part of our team. So, we are like in Cornelius' team where we are together, we are like 13 or 20, 13 people. And we are all working on different engagements. So we used to like share experience as well of what we have tried and built for other customers. So also we can learn like what people have been doing with generative AI, what are the use cases, and trying to bring those kind of sharing information and build something that could be useful for customers and for other engagement.
On your side, Cornelio?
Yeah, maybe I would say also the technical side where we build this in TypeScript and Python. I mean, you don't do it the same way in both languages. So it was a challenge to make it work seamlessly, whatever language you're using. And I would say, spend a lot of time. Like I said, the framework allows you to combine agents that can do streaming or not. And this is not that easy to build, I mean, out of the box. So we spend a lot of time to make it work, which means you call the orchestrator, you get the response either in chunks or at once, which is kind of cool, I think. But it was not easy to build, to implement. So, yeah.
Would it be possible to hide the implementation behind an API and to talk to the framework through a REST API, for example? Because if I understand right now, it's a library that we include in TypeScript or Python inside our code, and we make direct function call. What about isolating it in terms of programming language?
Yeah, of course. Yeah, it's totally possible.
I think, as part of our GitHub, we provided like few examples of like how you could use our orchestrator through a web chat, for example, web interface. We provide like implementation of using our orchestrator through Lambda URL, for example, or within a Chainlit application, like how this will work. We also have an example with Fast API as well, which is quite common when using Python. So we try to provide all of those kind of integration to see for end user how they would be able to make use of that through their like preferred environment.
Yeah, I don't know. I don't see it something that I would change.
Yeah.
I mean, first of all, I think we not only worked really well on this, we had the same ideas from the beginning, which helps a lot when you work where you don't work alone. I don't know. What do you think, Anthony?
No, I think we are lucky to get this working again from like the exploration 8 months ago, at the same time as Sonnet 3.5 was released. Because when we start doing this, we didn't have Sonnet 3.5, but our main kind of architecture for the framework was already there. I think at the end it was just trying to find the best LLM that would cover like general use cases to be able to classify the request and call the right agent. And so using Sonnet 3.5 with Bedrock was really a game changer at that point. So
it was a good timing to have Anthropic releasing Sonnet 3.5 just at the time you needed, and you really observe a difference of quality in the response. I mean, going from not usable to good result, that's the range.
I think it was going from like it kind of works to it really works really. And the thing is, I think also one good thing that we have by using Amazon Bedrock is when we use the Converse API, you can easily switch from one model to another. And I think this really simplifies the way you want to build a generative AI application when you don't know exactly which model is going to work best. And by being able to really experiment quickly with different models really helped us in getting into a phase where, okay, this model really worked for this kind of prompt. Let's stick to that and continue our work.
I saw that you demonstrate the orchestrator as well internally during different types of meeting. I was wondering, is there already any like hackathon or game day or something where you put people inside in a room and trying to invent a use case based on the orchestrator, or maybe it's coming in the coming weeks or months?
But this multi-agent orchestrator has been used as part of generative AI bootcamp that we organize as part of our team. And as we are going through bootcamp, it's a really short time frame. So you really need to accelerate. And in order to accelerate, we reuse assets that we have built. And multi-agent orchestrator is a good asset because as you start having multiple agents, you can use this. What we have seen as well is people internally using our orchestrator as part of workshop that we didn't really know actually. At some point, people ping us and say, "Hey, look, we have been using this. We have a few issues. Can you help us?" So it's good that we don't know that people are using it.
To create with it, because as you said, it's an accelerator. It makes developing solution using generative AI much easier. What's coming next? We don't talk about roadmap, even if it is open source product, but I'm sure you have tons of ideas of improvements, new functionalities. Is there anything you can share right now?
For now, we are trying to create some more examples of what you can do with it, right? So, for example, for the email simulator, we have an example that is already on GitHub. We need to polish it a little bit. We want to give more examples for specific use case, which allows customers to understand better how you can use this. Not present the framework from a technical angle, but from a business perspective, or say, okay, how to do this, and then we'll show how to do the orchestrator, which allows, I think, to see more and how far you can bring this. And of course, we have like a long list of things. And just time is something that we don't have that much.
That's what I hear more and more as well from GenAI projects, is that let's start with a business case first, and then we'll see what the technology can do. So bringing business use case first and see how the orchestrator can help. It's a good idea. So your answer is mostly working on the doc, on the example, on the business use cases, so that people can get it and get started quickly. Give it a try. That's my call to action. It's open source. It's on GitHub. It's quite easy to get started. It's TypeScript and Python, so it's as easy as pip install in Python to get started, and then pm install on TypeScript. You can contribute as well. It's open source, so PRs are welcome, pull requests are welcome. But it's not the only way to contribute to open source projects. I always say that entering an issue, a code sample, improving the documentation, these are valuable contribution as well. Anything you want to add, Corneliu, Anthony?
No, like you said, go on our GitHub page. You have documentation, have examples for many usages. And for example, for the video with Amazon Connect, there's even a demo video that is hosted on YouTube. You can see how that works in action. Give us a star if you want. And like you said, yeah, we need more people to create issues, to ask us things, because no one asks. I mean, we don't know what to create. Other than we are using ourselves in our engagement, so we know what is missing, but we are more than happy to have other people, other customers asking things.
It's easy to find. It's on github.com/AWS/multi-agent orchestrator with dashes, but of course the link is in the notes of this podcast. So in whatever podcast application you are, you just scroll down a bit through the notes and you will find the link there. Thank you, Corneliu. Thank you, Anthony, for explaining the multi-agent orchestrator, why you created it, how it's working behind the scene, how to use it from a developer perspective. Thank you for having listened to this episode until the end. And let's meet next week, Friday morning, in all your podcast application. But now, go build.